Thanks for having me. I'm quite honored to be able to have this opportunity to speak at the vodQA meetup. So the topic for today that I'm gonna talk about is called Visual Testing ToolBox. It's something I also shared at the meetup in Singapore, and I did a like 3-minute lightning talk at the Selenium conference, but today is going to be a little bit longer, so I can go into much more detail. So the background for this is usually when we think about visual testing, what comes to mind first is visual regression testing, where you have a baseline image, and then when you run your regression test, you check the current state of the app against that baseline. And there are a lot of commercial tools that are able to achieve this, Applitools or Percy, and a couple others. And they're all very useful and good for their purpose, but sometimes you might not need something as powerful. And there are actually some very good open source tools that can also help you with your visual testing use cases. And that's what I want to share about today, and show how we can integrate that into Selenium or Appium test framework. So I'm gonna do a little bit of like 3 main theory parts first, and then in the end we'll have time for a longer demo. So the first use case I want to talk about is called template matching. So imagine you have a template image, which is here on the right side, and you want to find it on the screen of your application under test. So this could be a web page, it could be a native app. You just want to check whether that image is appearing on the screen. Usually in practice, the use case will be much simpler than this one, but it's just for demonstration. So you want to find that image, and also you want to be able to interact with it. And I'm going to show later how you can use a Selenium locator to make that work. The tool for that you can use is called OpenCV. It's a, I think, C library that has a Java wrapper as well. And there's also a Python version, so it's very easy to integrate into existing frameworks. Actually, this is also what Appium is using. So maybe some of you are familiar with the image locator in Appium, those of you who do mobile testing. The way it works in Appium is that you send a request to the Appium server saying, I want to locate this element by an image, and you pass the image encoded as a base64 string to Appium. And then Appium will take a screenshot of the phone and use OpenCV to check whether that template image is present on the screen, and then return you the result. So it all works on the server side. The other way of doing it, and this is what I'm going to demonstrate, works with Appium, but also with Selenium, which does not have an inbuilt image locator strategy yet. But this could be used to build one very easily. And as far as I'm aware, there are some plans for Selenium 4 to make it much easier to have custom locator strategies. And yeah, that, in my opinion, could be one good use case. So we go into the code samples later, but in the end, it should be as easy as having a find image method. You pass, in this case, I pass the file name of that file. So I have this as part of my test repository as well. I prefer that to using base64 strings because they get quite long, especially if you have larger images. And the cool thing is that we're going to return a web element which you can interact with. So it's not just going to tell you whether this element is visible on the screen or not, but you can also, for example, click on it. So we do all the demos in the end. The second one is layout testing, which is also a subset of what you can do with visual testing. Because sometimes the use case might be, I just want to make sure that all the elements on my UI are in the right place, like absolutely or in relation to each other. So for example, I might want to check that the Google logo is on top of the search bar and not somewhere else. So if I, let's say if I just use Selenium test without visual testing, as long as the elements are in the DOM and visible on the screen, my test will pass. But that does not tell me that the design is actually usable for real user. So I could use like pixel-based or image-based visual testing, where I have a baseline and I compare my current screen against that and see whether there is any derivation. But that's not necessary if I'm just concerned with the position. So layout-based testing, you can use a tool that's called Galen. It's a very nice Java-based test framework, quite underrated in my opinion. I don't know of a lot of people using that. Well, it's very, very powerful. And the nice thing is that you define how your screen looks like in a textual format. So, so you have the UI elements that you want to interact with. If we go back, so this is the logo, the search button, and the search field. And then I can describe how they need to be positioned to each other. So for example, I want the search field to be below the logo. I want it to be horizontally centered within the viewport of my browser. And of course, I want it to be visible. And then I can have similar checks for the other UI elements. And these are just simple examples. Galen supports a variety of much more complicated checks. So instead of doing like pixel-based comparison, I describe my UI in this textual format. It's called a Galen spec file. And then I just, so the way I implemented it, you just call a verify method on the page object if you're using page object model. And so every time a new page or a new screen is loaded, I can call verify, and then the framework will do a couple of checks, one of which is to call Galen and verify that the layout is matching the specification. And then, yeah, there is a nice report that we can use. The third example I'd like to share is optical character recognition, OCR. Depends on what kind of application you're testing, how useful this is going to be for you. But sometimes there are situations where you need to verify a text in an element that is not actually rendered as a text, but is rendered within an image. And in such a situation, it would be very useful to already have a tool in place that can do that for you. And again, there is a very powerful C library that we can use. It's called Tesseract. Was developed way back in, I think, the 80s by Hewlett-Packard. And is currently maintained as open source by Google. So it's actively maintained and really powerful OCR tool. And you can also integrate it with any Java-based framework because there is a Java wrapper called Test4j. So if you use Maven, this is as easy as to integrate that into your framework. Again, we'll look at the code in a bit. Oh, sorry. And then, yeah, the checks can be as simple as calling get text with and passing a web element, a Selenium web element to that OCR service. Or when we're using the find image from the previous example, that returns a web element, and I can call get text on that and implement it in such a way that this will call the OCR, the Tesseract service, and return me the text. So I can very easily, in a quite natural way, like how I interact with other elements in Selenium, get the text of an image. Okay, that was just a quick introduction. I actually want to spend most of my time doing the demo. So it was mentioned during the introduction that I'm maintainer of a Java test framework. It's called Just Testla, which actually started as a demo project for some of the talks I gave during meetups to actually demonstrate the code and the concept that I talked about, because I always want to have a working example and not just do slides. So over time it grew quite a bit, and I think now it reached a point where it could actually be useful for others. So I want to share that. So also please feel free to try it out. So for the demo, what you're going to use, it's based on that test framework, which uses Selenium, Appium, and is written in Java. Supports almost all Java versions greater than 10, but there's some restriction. If you want to do image recognition with OpenCV, it does not yet work above Java 11. So we're going to use Java 11 for this. And Maven as a build tool, you can try, should work with Gradle as well. And yeah, we'll use OpenCV and Tesseract. Those might be a little bit tricky to install on your machine, but there's quite good documentation on that as well. Because if you want to use like Tesseract, even though there's a Java wrapper, you still need to install the native libraries on your machine as well. Okay. Yeah, so without further ado, let's do some demos. So the way I've set it up is there is something called a Maven archetype, which is a very useful way to set up a prototype or a quick start project. So it's also in the documentation in the link that I shared. And yeah, by calling it like this, we can use the quick start artifact archetype to generate a demo project. So I just say, okay, group ID, vodQA and demo. Actually, give me 1 second. We want visual testing and Galen as well. Yes. Okay, and this will auto-generate the Maven project. And we can do a first quick test to see whether this worked. This will build the project and run a very simple demo test, which just opens up the browser, opens Google, and does some verifications. And yeah, that works. So next, we're gonna import this into our IDE. Is my screen still visible? Can you see my Eclipse?
Yes, Marta.
Okay, thank you.
Yeah.
So now I can import this as a Maven project. And there's a simple runner class. So just to try it once more, let's run this from Eclipse as well. And I should do the same thing. Okay. The test is not very interesting yet, but we'll make it a little bit nicer. Yeah, so you can see in the log output the different steps and some entry exit logging. Also can see, okay, right now we're not generating any Galen reports because we haven't specified the spec yet. So what I'm using is also using Cucumber. So these are feature-driven tests. So the very, very basic test just for demo purposes. I'm on the homepage, I search for something, and then there should be some search results. Now, the first thing I want to do is do the layout testing. So if we quickly go back to the slides. So I want to verify that the position of the elements is correct. So the framework uses a page object model. So I have in this example just one page for the search page. And I already have a couple of UI elements. And the way it is set up is to every Java class, there is a corresponding YAML file which defines the locators. You can do this differently. You can also put it in the Java file itself. This is just the way that I find most useful. Now we're gonna create the spec file for Galen. Go page.spec. And like just Tesla can work with different platforms. So it's web, Android, iOS using Appium. So we need to specify, okay, this is the spec file for web. And here, let me just actually, let's copy paste this whole thing. Also, I think we don't have a locator for the logo yet because I don't use it in the test. Sorry, let me just copy that from another example. So the way these YAML files are built is this is the ID, the locator, then the platform. So we can have the same locator for different platforms. So for example, for Android, this could look, yeah, something like this, and then it has a different ID on Android, or I use different locator strategy for different platforms. But that's not important for today's talk. Yeah, so the logo I'll identify using ID. And this is our spec file for Galen. Then just need to make sure that we enable the Galen checks. The dependency should already be there. All right. Yeah, let's save that and let's try to run the test again. I think I made some mistake. Sorry, give me 1 second. Okay. And login is probably wrong. We should give a different name. So yeah, it's my mistake. This header was missing. So now you can see in the log file that we're actually generating one Galen report. And if we check our target directory, okay. That should show some results. Okay, never mind. I'll show the full demo at the end. I don't know what's the problem there. Okay, the next thing I want to demo is how to actually do image detection. So if we go back to our feature file, let's add a step here. So given I'm on the homepage, then I see the Google logo. So how can we implement that? So we need to have corresponding step. And then let's implement something on the page object to check whether the logo is there. Okay. Okay, and here what we can do is every page object extends from a base page. So there is a method find image to which I can pass a file name. And this file needs to be in a directory called images on my class path. So let's create that now. Images. Again, I have some other demo and I just copy it from there to save some time. And the cool thing about this method is that it actually returns a web element. And it returns a custom implementation of the web element interface called image web element. So not all the functions are supported, but the important ones. So for example, using JavaScript, you can click on that element, and we'll see that later as well. So if I go back to the Google page object, the other important method that is implemented is displayed. So in this case, what I'm going to do, I just return find image is displayed. So if this returns true, that means that the image is visible on the screen. And if I didn't make any mistakes, then this should already work. Let's see. Okay, cool. So if you have a look at the log file, I highlight the step that we just implemented. I see the Google logo. Okay, entering the step, entering the has logo method on the page, and then this is the interesting part for the image detection. We create a screenshot using the WebDriver. And we also use the template, which in this case is the Google logo, and pass it to this OpenCV template matcher. I'll show the code in a second. And then it says, okay, this was found with match quality of 0.9999, so more than 99% accuracy. So you can set a threshold and see and define how close the match need to be. That allows you to not need to be pixel perfect. You can maybe if the scaling is a bit off or other things are a little bit off, you can still decide that this is a match for you. But in this case, it's as close as we can get. And also defines where has it been found. And then let me show you this as well. Sorry. I'll show this later as well. Let's go to the template matcher. So what this does is basically a wrapper around the OpenCV library. And there is a match method that takes the target and the template. So the target is, in our case, is always the screen itself. And the template is the image we want to find there. And then using this OpenCV method called match template to see whether a match has been found. The other logic is almost entirely for scaling. So in order to support matching images that are in a different size, we use a very simple scaling algorithm that just tries to find the image in the original size. If it doesn't find it, scales up and down the original image by 10%, then checks again until either a match is found or some max size has been reached. So this allows it to adapt to some scaling inaccuracies. And then at the end, we return a match object, which is basically just a rectangle. It says, okay, this is the X, and these are the X and Y coordinates of my match. And this is the width and the height. And based on that, we can then generate a web element. So this happens right now in the base page. There is this find image method. Yeah, the important part is here where we call the template matcher with our screenshot and our template. We get the rectangle. This is just basically the Selenium implementation of a rectangle, which I think is from Java Auth. And based on that, we then create an image web element, which implements the Selenium interface for web element. And then we can do very nice things, like, for example, this only works in the browser. Click on that element. So based on X and Y coordinates and the width and height, we can click right in the center of the element that has been found. And yeah, that I think could be used to build a Selenium locator for this. Yeah, and let's do one last improvement to this. So instead of just checking whether the logo is there, what we now want to do, wait, why is this still? Okay. What we now want to check is that the text actually says Google. So we change this from a Boolean to a string. So get logo text. And now, since web element already supports get text, we just need to implement that using OCR. And then what we can do in our step, get logo text, and we check whether this is equal to Google. And let's see. I think this will fail first. Yeah. So the error is Tesseract data path is not set. So we need to specify the path to our Tesseract data. Now let's do this. Let me copy this from the documentation. Yeah, I think in my case it looks like this. So again, we go back to our demo project. We just specified, this will depend on your operating system and the path where you install Tesseract. And now we run it again. And this time it passes. And as you can see, it still runs pretty fast. And if you check the log file, now what happens is, again, the OpenCV image detection, and then we perform OCR on that image. And then it says, okay, I found text Google, and the test passes. So basically what we did is we took a screenshot of this image, pass it to an OCR, and get the text out of it. And this is already not the simplest use case for OCR, because this is not an easy font. It's not quite straightforward to parse. So if you have like proper text, this should work even better. Okay, I think that's more or less it. Let me just also run another example where you can actually see that we can also click on these elements. So again, yeah, okay, we know this one. All right. So again, we go to Google page, we search for something, then there is a small Google logo on the left side of the search results page. We find this, and then we use the method that I just showed you to click on it. So this is to show that you can actually interact with the elements you find using this. So finally, before I wrap up, let me also show you the OCR source code. This is very straightforward. This is basically really just a wrapper around the test4j. So we get a screenshot of a web element. Then we call get text, and that calls do OCR on that file. And then we trim the white spaces and we return. Okay. Yeah, that's all the demos that I had, except I think I still owe you yeah. When we do the image detection, it says writing visualization of template matching to some file in the target folder. This is this file. So you can, we highlight where on the screen the element was found. So this is for debugging purposes, sometimes can be useful, especially if you have very similar elements. Sometimes there might be a mismatch, so you can easily see which element has been identified. Okay, I hope I didn't forget anything. Oh yeah, the Galen report. Let's see that as well. Yes. Actually, this is one where it failed. Okay, maybe. Yeah. So the way it looks like is, okay, this is the page. Misspelled it and misnamed it login, but you get the point. And these are the elements, and these are all the checks that have been executed. And there's also some nice visualization to verify it. So for example, I want the logo to be above the search field, and I can see it is by 32 pixels. So this is quite a useful tool, and Galen is completely open source. So if you have similar use case, I can highly recommend that. Yeah, so that's all I have. There's also a Medium article, like companion article to this talk. If you want to go into a little bit more detail, I'll share the link. And I think we can share the slides as well. So yeah, thank you very much for having me.